In number 24, we need to determine if x minus 6 is a factor of p of x is equal to x to the fourth minus 32x squared minus 144 using synthetic division, and then if it is, write the polynomial as a product of its linear factors. So we're going to start with taking our first factor, which is x minus 6, and we're going to synthetically divide that in our polynomial. So we take the 0, not the actual number that's in the factor. So the 0 is positive 6. And now we're going to plug that into our synthetic division using our coefficients. So we have 1 for the x to the fourth term, 0 for the x cubed term, negative 32 for the x squared term, 0 for the x term, and negative 144 for the constant. And as synthetic division goes, we add those two together. So we have bring down the 1, multiply by 6, add it to the next column, and we add going down, and then repeat that process. So we get 0 as our factor, or as our remainder, which is a good thing, because now that we know that the remainder is 0, then we know that x minus 6 is actually a 0, a factor that turns into a 0. So now we can rewrite this polynomial as a function, because 24 is our constant term, 4 is our x to the first, 6 is our x squared, and 1 is our x cubed term. So let's write that out. 1x cubed plus 6x squared plus 4x plus 24. So now we have to figure out how to determine the other linear factors. So this method changes depending on what you're given in the problem. If we knew another 0, we could use synthetic division again, but we don't, so instead we need to evaluate this polynomial and decide what's the best method. In this case, we have a polynomial of 4 terms, which we can use factoring by grouping 4. So in our first set of 2 terms, we'll take out an x squared, and we're left with x plus 6. In the second set of 2 terms, we'll take out a plus 4, and also left with x plus 6. X plus 6 is a common factor, so that's my first factor, and x squared plus 4 is what's left over when you factor out the x plus 6, so that's my second factor. So far we have all of these factors, x plus 6, x minus 6, and x squared plus 4. But x squared plus 4 is non-linear, so that means we need to keep breaking that one down. So if we set this equal to 0, we can subtract 4, then take the square root of negative 4, which is plus or minus 2i. So now I have my remaining 2 linear factors. So if I write this in factored form, I have x plus 2i, x minus 2i. Then from our new polynomial, we have x plus 6, and then our original factor, x minus 6. So together, our polynomial p of x broken down into all linear factors is x plus 2i, x minus 2i, x plus 6, x minus 6, and we are done.